Okay, hi everybody. Is the sound correct now? Okay, so welcome on this very new stream, the first in a long time, since June, I think. Can hear me. Okay, great. So yeah, long time no see. Back to school, or back to work, let's say. I hope your holidays were nice. Mine sure were. Today we will change the program compared to as usual. We usually work on OpenHT, and we will now focus on Module 17. So to get going immediately, and this is Taiga. So Taiga is a project management solution that we decided to try for now and see if we can have it working for us as a test first on Module 17. So Module 17, briefly what it is. So I don't have any with me yet. The Belgian customs are making it hard for me to get them. But those are boards about this size, let's say, with a small screen, microphone, a few keys, which allow you to turn your traditional FM radio using the packet radio port in a M17 capable radio. So basically this is like TNC, maybe some will know the word TNC, Terminal Node Controller. We use the word modem because it just does the modulation demodulation from M17. And we are now using the revision V0.1E. I think, yeah. So there were quite a few iterations, and we think that now we are able to converge to a stable release, which we will call V1, and then propose the design to everybody to be able to popularize a bit more M17 compared to what it is now, which is already quite good. Okay, so Taiga, as I said, which is a project management solution. We decided to try that because we see that we are not that many working on Module 17, and whenever somebody comes up asking for how he or she can help, we usually don't have a readily available answer. We have to discuss between us and see, and this can quickly be a mess, and basically this is more work for us than it should be. So we think that using such a solution will help us having better organization and be able to include people more easily in the process and the development process. So Module 17 is the first test. I think for now it's going quite great. This tool is able to do Scrum project management, which I'm not familiar with at all, but the interface seems to be quite intuitive, so I think I got it in a state which is at least able to help us doing what we need to do. So you can see that we have the backlog. Let's see, I think I can just status. Okay, we have a few points that we want to address later on, but now not in the revision one. So don't worry, there is still plenty of work to do on Module 17. But yeah, for revision 1 specifically, we picked a few points that we want to address. What I think we could do quickly is go through those and then start working on them. So first, so this is an issue that's appeared, I think. So yeah, just before we get going to, this is the first time I will be really working on Module 17. This is not my original design, so I will have to get familiar with it too. So maybe there will be some back and forth, I don't know yet, we will see. So first, the first story or point to address that we have in front of us. Yeah, it appeared between the revision 0.1D and 0.1E, which is that we were using E potentiometer or electronically trimmable potentiometer, whatever you call them. And because of the electronic component shortages, we had a hard time sourcing them, and it was making the design quite more difficult. So we decided to add multi-turn potentiometers, which made the revision 0.1e. But now that the electronic potentiometers are available, more available than before, we would like to reintegrate them back in the design. So OpenRTX, which is the firmware that runs on Module 17, is able to detect if we have the e-potentiometer or not. So what we would like to do is have both the e-potentiometer and the multi-turn potentiometer on the board. And whenever you decide to assemble them, you will just pick if you want the e-potentiometer or the multi-turn potentiometer. And so this should be much easier to do. This will make the board more easy to produce, given that we have multiple choices. I think by default it will be the e-potentiometer as well as the multi-turn one. Sorry, I'm getting tired already and it's only getting started. By default it will be the e-potentiometer, and if you can't source them, then you will be able to place just a few multi-turn ones. Okay, the second story here is what is called OHIS connector, open source headset interconnect standard, I think, which you can know more about on ohis.org. Yeah, open headset interconnect standard, yes. So basically, for now we use a Kenwood connector, which is sorry, I think I do have one somewhere. Let me pick it. Which is a solution which is used on those cheapo Chinese speaker mics. So this is what the plug looks like. Let me just get my video feedback, so that I know if you. Yeah, okay. So this is what it looks like. You have two jacks, 3.5 and 2.5 millimeter, which are, I think, 11 millimeters apart. One is for the microphone, one is for the speaker. The problem is that it seems that several manufacturers decided to opt for this standard. Well, at least decided to opt for this physical form factor, but there is no standard behind it. So it means that some use the small plug for the microphone, some use it for the speaker. This can quickly get a mess, and we think that some people may have broken their Module 17 because of an improper speaker mic connection. So we will also need to add some notes on the PCB telling that it's only compatible with the cheapo Chinese ones, not the Yaesu or ICOM ones, but we will add the OHIS connector, which is an open standard. So if you go here, you can see the standard, how it's designed, the levels that are expected on each port, and the goal of this project. So basically, yeah, you have an OHIS port on your radio, you use any adapter that you design. You can design it yourself, given that the standard is available, and then you can plug whatever you want on the other side. So Module 17, I think, might be the first device having it, from what I've understood. We'll see how it goes, but we do believe that it can be a good idea going forward. Okay, so next step, it's a big one, aluminum chassis. So basically, we would like to enclose Module 17 in a box. Aluminum box, which will make it much more high quality looking. But this will force us to first modify the PCB shape. First pick a box, then modify the PCB shape, and then we will have to move around the connectors, inputs, outputs, add a breakout for the buttons, stuff like that. So we'll see how it goes too. But yeah, this is one of the major points in this revision. Then we just have a few resistors that we have to modify, because Just the board revision wasn't being detected properly. So we'll see for that, but we have sets already and we know what we have to use. Then we have the audio output rework, because using those in the latest revision, it seems that the audio output is very, very low, and it's barely, you can barely hear it. So we will have to fix that, but we think that we found some flaws in the schematic, and so we will have to address those. And then we have a shutdown issue, which basically means that the Module 17 can't shut itself down, and it's just a pull down that needs to be added. We also have the footprints for the TCXO, which we would like to remove because we don't use it. It's been not placed on the board for quite a few revisions, I think. We do believe that the crystal that we use is enough, given that I think Module 17 is M17 is supposed to have some kind of clock recovery mechanism, which should make it possible to use more classical crystals. But yeah, maybe we could opt for some ICOM or Yezu way to do, which is that you will have the standard crystal by default, and if you want the high precision one, then it will be $150. Who knows? But no, basically the microcontroller can have an output from a TCXO if you just solder a wire on any pad from the crystal. So you can just remove the crystal and add a higher precision source, whatever it is, TCXO, JPSDO, whatever. So yeah, this is quite quickly what we want to do for this revision. We think that including this will make Module 17 much easier to use, and we will then be able to start getting interested in how to get it manufactured more in a higher production level, and then make it so that you maybe can buy it more easily than having to gather a few friends to buy some. Okay, so I think we will get started with the very fast ones, like shutdown issue, which is just add a 10K pull down resistor. So we'll have a look here. Okay. It's not starting very well because I don't remember why I have to place this one. Okay, let me just call. Okay, we'll first start KiCad and open the schematic. Okay, so for those who have never seen it, this is the Module 17 schematic. This is the microcontroller part. So very briefly, you have the microcontroller here, this large yellow box, USB-C connector here with ESD protections and so on. You have a barrel jack for the 12-volt inputs, which goes to GPIO, which can, I think it should be like about here, that you have to add the pull-down resistor probably. Then you have a regulator, DC-DC converter to 5 volts. And then this one to VDD, which I think is 3.3 volts. I think this would hint at that. Buttons and keys to control the device, a few color LEDs, and the crystal. Yeah, this maybe we can just also remove it. Just like this. This will need to change. This is for the revision detection. And then on the second sheet, you have everything which is audio related. So you have the audio which goes to the speaker, which starts here, low pass filter. This is, I think, for the volume, so this is the multi-turn potentiometer that we are gonna have to replace with electronic ones, I think. Or no, sorry, no, that's not that one. It's, oh, I don't know actually. Oh, I realize that I don't know that much about the design. Radio RX goes here. Okay, baseband RX. I think this is one of the potentiometer that you have to change. And then there is baseband TX and this one. So yeah, those are, this is an amplification. And so this, yeah, okay, this will amplify the baseband signal, and thus the deviation, I think it is going to change the deviation, and so that's the one we need to change. Anyway, I think I can also go have a look in previous revisions to see how it was done. So those, yeah, are the baseband, let's say, treatment parts. Then we have here the speaker output. So this is a speaker power amplifier, and this is the speaker that goes to the speaker directly. So we have here a low pass filter, and this, I guess, is for the volume. I'm not sure. This is from the microphone, and then we have this circuit which allows to set the microphone gain, and then goes to the MCU, which will sample it. Those two connectors, Kenwood connectors, are those which are used for this plug. This one is a DE9 connector, which is used for the packet radio connection. And we have also breakouts of this to a standard header. And this, I guess, is like level conversion, something like that. And then, yeah, PTT, I guess this is same level conversion, something like that. Okay. Yeah, DE9, Steve, isn't it what I said? So hello, Bartos, or whatever your name is when it's pronounced correctly. Okay, so what did I say that was starting with? Okay, shutdown issue. So this probably is in the microcontroller part. Oh, okay, you were just excited. Hi, Pierre. How are you? Long time no see. Okay, where does this one go? Okay, I see. Okay, so yeah, the shutdown issue. GPIO power, I guess this one, well, does control the power, so I guess maybe a pull down like somewhere here would help. PA15 and pin 1 of D7. Yeah, okay, and okay, so I guess this means yeah, okay, on the GPIO power net. Okay, great. Oh. We had a low valued resistor in one of the design between one of the MCU pins and the crystal. What? That doesn't make any sense. So you wouldn't put usually any resistor, I think, between the crystal and the MCU pins. You only have like those capacitors, which have to be tuned to the crystal. And pH0 can be used as a clock input. So maybe we will. Oh, it might ask for it. Well, let's see. Well, this can quickly get very long checking for this. Don't we have like getting started hardware development? This should show us the bare minimum circuit. Oh. Okay, first time I see this. Why not? Hi, Jens. Okay. Yeah, we learn every day. Yes, of course. Otherwise, I would be very sad. Figure 16. Okay. Well, I'm sad to say that Z80 is a bit too old for me to know about. Sorry. You have resonators, and I guess crystals would be. Well, you know what? Maybe let's because I'm gonna get lost if I change the topic every now and then just because I saw something. Story list tasks. Let's add subjects. So what is it called? Rx. No, we don't. Okay. Well, okay. I'm just gonna create the task, and we are gonna have a look at that later on. But yeah, okay. So it's it has been tried, yeah, already, and it was decided to remove it. So, okay, whatever. What I was trying to do was to add a pull-down resistor right here, and maybe I can try to move things up a bit so I can have more room. Yeah, good point, Mattis. I can join the voice channel. Maybe let's join the voice channel right now. So whoever wants to join is free to join. Okay, so well, Wojciech, maybe whenever you have some time, you can add a comment to the task that we should maybe at least add a 0 ohm resistor later on. Oh yeah, no music, right. Let's try to find a new playlist this year. Do we have different channels that we can go to? Yeah, this YouTube channel links itself. Why not? Okay, what should we play? What kind of music? Do you have anything which looks like interesting? Okay, how is the volume? Maybe you can tell me if it's loud enough or not enough. In the meantime, I'm gonna add a 10 kilo ohm resistor. Hard style. Next stream maybe. Why not? Can be fun. Okay, yeah, not a lot of space here for this resistor. Also, why is it called 301? How many resistors do we have? Okay, looks like the last one is R57. Oh no, it goes up higher than that. 65, 67. $10 kilo run gun. Can I get all this a bit higher? Okay, great. I prefer like this, and so we can get this up a bit. Good. Looks good. Okay, so this is all we needed for the 10K for the shutdown issue. Maybe let's go step by step and switch to the PCB and see if I can import the changes. One error, what is it? Oh yeah, no footprint, of course. Let's see. Okay, and I think we do need to add a few, yeah, something like this. Oh yeah, you're right. The pull down is bigger. It was a smaller R that was used. Yeah, this is more like it. Okay, happy, Wojciech? The resistors are now consistent. Great, so now I can go to the board and I can import them, so okay, what is being done? Info I don't need. Add a net. Reconnect C3 pin 2 from TCXO to, okay, yeah, update D8, D9, IC1 RV2. Oh, D8, D9 might be from changes that I did. Hi. D8, D9, I think this is from some, yeah, this one, this resistor, yeah, those are changes that I made previously before the stream. IC1, what is it? Oh, I have to. IC1. IC1 is that one. Okay, so it looks like we did some changes. Okay, no worries. Okay, we will just import the changes. Update the board. Have this new resistor to add. And we have to add it near GPIO power. And okay, let's add it here. Oh, this grid is way too large. Oh my god, what was the grid that was picked for this? Oh my god, no. What the hell? Nothing is aligned. Oh, I think maybe I moved the reference. Oh god, no. Fuck. That's... Okay, well, we'll have to live with it. And yeah, except that now we are completely in the screen, silk screen, which is no good. Where can I add this then? In order to not be in the silk screen in the middle of the... Well, maybe I shouldn't worry too much, because I do believe that the design is expected to change at some point because of the aluminum box that we want to add. So maybe let's just add it around here. I'm gonna try to keep the changes as incremental as possible. So I have just added this here. And so yeah, this should be enough. So it's a bit weird on an angle like this, but yeah, whatever. I'm just gonna check on the PCB file what were the changes. Okay, copper finish, some nets, path, nets, part number. Okay, we removed fields, modified some part numbers, removed like other fields that were not needed, and yeah, okay, so that were the changes that we saw when we imported the changes to the board. Okay, all right, so this is good. I'm just gonna do a separate commit for the first changes that I did previously, so that I don't mix everything together. How do they call it? Fields. And then oh yeah, of course, I did two things. Okay, I think this. Why did everything move? Oh, what is going on? Oh no, okay, it's okay, that was all right. Nope, not that one, I think. Oh, I'm getting confused. Okay, you know what? Let's try. This first. Okay, sorry, this is not the most fun part of the stream, but I'm trying to stay as organized as I can. So this here. And also, yeah, okay, those need to be removed. R68, oh wait, no, X1, C22, 24, 26. Where are those? I guess near the MCU. So this would be, yeah, TCXO. Okay, and so also this. Oh god. What did I do? Okay, yeah, no, we'll just keep going. This nets have been renamed. Oh my god. Oh no. KitKat, what did you do? Okay, and so now we can stage this, and we can put this as removed and use TCXO. And now we can go back to the schematic, revert this, re-import this. Put it at an angle, just like we did before. And put some vias. And then we can do this. Okay, yeah, like this, and do okay, I think we had an issue on GitHub for this one, so let's tag it. Oh, let's sign in. Let me do that off screen. Okay, we don't have any issues actually. So, okay, well, no issue means no tag.
Morgan,
Yeah,
Good
hi.
evening, man.
Hey, good evening. Oh,
what are you doing here?
I'm streaming for the Module17 Revision 1.
Okay, nice.
Yeah, so who is it? I don't see really the names on Discord, and I don't think I've seen you in the past, but yeah, you're welcome to join, of course.
We are
Yeah.
new here.
So do you have the link to the stream?
No.
Okay, you can have a look on the M17 YouTube channel or Twitch channel.
Okay,
So basically I've been streaming, I'm currently streaming the Revision 1 process, the migration to Revision 1.
Oh,
So which
really?
includes a few updates on the board, few changes that need to be done here and there, and then we'll have few bigger ones, such as probably nearly a whole board redesign to be able to fit it in an enclosure and a few connectors and stuff like that, and redesign with the audio output part because it's now not loud enough.
oh, and
Very
that sounds
nice.
great.
Yeah, we are quite hyped for this one. We really hope that we will be able to get it working
Yeah.
soon.
How many are you working on it? How many people?
Sorry?
How many people is working on it?
For now, there is only me. So previously in the past, it was Mattis Schmitter, DB9M80.
Mm-hmm.
But I think he is quite busy with work and, if I'm not mistaken, PhD, stuff like this.
Oh,
Yeah.
So yeah, for now I'm doing it.
but do you know
over
when
the
it will be
holiday.
done? Like 2 weeks or?
In the Taiga, so Taiga, it's a project management solution that we have, and just so you know, guys, that you are currently in the stream. Okay, so there is no issue with you
Oh, that's fine.
being on the stream. Okay. So yeah, we have a project solution that we call Taiga, which is used to basically manage the tasks that we have to do for this revision, and yeah, I think I'm getting lost in where I was going with whatever I was saying, but okay. Remove unpopulated TCX, so this has been removed.
Then I guess we will just check out the stream and we will maybe see you later.
Yeah, okay. See you later, guys.
See you.
Bye. Okay, remove unpopulated TCX, so it's done. Hi, Yorbe, how are you? Welcome on the stream. Okay, so this one's closed, which should put it... Okay, Taiga is getting slow today. Okay, this is closed, and so this can be changed to close to, I think. And let me maybe tag the commits. Okay, so this is the commit in which it has been done. And we also have added the pull down for the shutdown too. So let's do the same for that one. Copy the commit, shutdown issue, this is the task, so I'm gonna just close the task. shutdown issue here. Yeah, okay. Like this, and this is closed. Okay, so we closed 2 issues already, which is great. Maybe the next one I would like to do is the OHIS connector, because this should be quite easy to do. Let me maybe just rename this branch, if I can. Yeah, let's call it revision 1.0. Can I rename the branch and the remote or not? I don't know if I can rename branch. Oh yeah, we can. Is it just like this? Yeah, okay. Rename branch. Great. And now maybe just pull. Yeah, great. Tying does not exist on origin. Yeah, I don't care. Okay, perfect. So this is great. So next is the OHIS connector, maybe. So I think we will have to add that one. Well, where do I have to add that one? Okay, all the connectors except the USB-C, but we don't care about that. Are in this one. Yeah, okay, so let's try to move the audio connectors down a bit. Can I just log those? Okay, aligned. This one here and that one just below it. Okay, and where do will we find the place to put the connector? Maybe we can move this on the side. And move this up a bit, can we? Okay, and then maybe we can find some room here for this. So we will first have to add what is called an APC. Yeah, just like this, and we don't need any LED. Do we want it shielded? I have no idea. Is there anything on this? in the standard. Let's see. Yeah, okay, it seems that it calls for a shield, so let's use the correct one. So looks like we can also oh, that's funny. I hope Steve is still looking. The 8P8C connector seems to be a generic for all of those, of which RJ45 is a type. So I guess if we have a look at, like, I know RG31, I don't know what it does look like. I have no idea. Is it? Oh, maybe it's just a kind of wiring. Okay, anyway, it calls for 8P8C. Let's use 8P8C. Right here, and then have a look at the pinouts. I'm gonna put this, maybe let's try to put it here so that you can have a look too. So 8 is headphone right. Okay, headphone right, it's gonna be speaker. Seven is ground. 6 is a microphone, which is mic here. 5 is ground. 4 is headphone left, so it's speaker because we use mono. So if I'm not mistaken, Jens, Cat5 cable is RJ45, and RJ45 is a kind of wiring that implies that you have 4 differential pairs, while maybe RJ31 and stuff like that might be different kind of wiring of the same connector, and 8P8C would be the very much known connector that we all use and call Ethernet connector or internet plug or whatever you call it. Okay, so we will keep going with 3, which is ground, 2, which PTT. And so I guess we only need to add the PTT on 2. Yeah, I think it's one of the reasons why. Sorry, I forgot the name of Mark. Yes, Mark. I think that's why he picked this kind of signal pinouts, so that you can use a Cat5 cable with each signal which is in a differential pair with its own ground, so that you avoid having too much radiation around. And yeah, but people have been quite adamant in telling us that it's 8P8C and not RJ45, so please don't mind if I use the termination that I've been told to use. Anyway, we also see that VCC power, and I've been told that by Mark that we don't really need it. So let me just check what I'm supposed to do if I don't have any. Doesn't look like there is anything about what to do with the VCC pin. Okay, DC power again. Okay, there is nothing stated, so I guess that I will just tie it to ground. Let me just tag maybe okay, just give me a minute. Looking at what we decided and what we said for OHIS. Okay, that's Smithy. Okay, so my guess is that we have to connect it to ground so that PTT is not just hanging with another random pair. But I asked Mark to provide us insight on this. Also, we said that we were gonna add some 0 ohm resistors in between the speaker channels and the pin so that we can see later on if we need to put a specific value to, because the speaker output is able to provide up to 1 watt output from the specification of the amplifier that we use here. And this might be a bit much for some speakers, some headphones, sorry. So in this case, we will add resistors in the path from the output to the connector. So for this, I'm just gonna pick a random resistor on the board. And R69, value 0 ohm. Oh, do I have any 0 ohm already on the board? Yeah, it's just 0, not 0R. Wait. Okay. How many R's? 70. You are 1 resistor too late. Sorry. Well, actually, I think some have been removed, so maybe there is not exactly 70 of them. Okay. And then we are gonna place some grounds. Hoopla. Okay, so it looks like we are done for the OHIS connector, which was quite easy to do. But this is not the main goal of the revision one either, so shouldn't take too much time. Okay, let's add a note on here. Okay, also let's have a look at J12, so maybe let's do J13. Okay, let's see Taiga. How I split it. Yeah, okay, I just did that's okay. I have no idea if we have any space on the board to route that. I don't think we do. Yeah, the board is quite crowded actually. So yeah, I don't think we will be able to go much further without reworking the board, sadly. Well, let's add it to the schematic first. and I'm gonna split the task. And then this, I think we will. Yeah, yes, if we will probably be increasing the board size, at least for it to fit in the enclosure. I haven't seen the specification of the enclosure that have been discussed. So maybe we can do that. Yeah, we'll probably have the space for that. Okay, number 44. Okay, so we can see that this and this is blocked for now. We also have the potentiometers. I do believe that I will wait for... sorry, I think I will wait for the new board too. This is a bit more complex, and this will... okay, this maybe we need a bit more information too, because I haven't seen clearly if we want to modify the the audio power amplifier or not. Okay, what the hell? Oh fuck, shit. Oh, oh, interesting. Sorry, Steve, I did some... I messed up. I temporarily removed the restream bot from the moderator team, wanting to remove its message from the spam. Yeah, maybe if it keeps... if we only get spams from Twitch, we will quit streaming on Twitch. And I'm not a moderator on the channel, so can somebody have a look at the spam, please? So what I was saying is that for the potentiometer, I want to wait for the next... it's not mandatory, but I want to wait for the next PCB shape, because there is no point in modifying it if we in placing them if we change the board again, especially now that we know that we want to have the multi-turn potentiometers changed to small ones which are close to the edge of the PCB so that we can tune them with small screwdrivers. The new audio amplifier and so on, I don't know that. I think Wojciech was tasked with finding a Class D amplifier, but it looks like there is no really any audio amplifier that we can use other than the one we have, because Class D amplifier have to be symmetric outputs, yeah, so differential outputs, while the OHIS connector forces us to have single-ended outputs. So that we still have to decide. And it's Wojciech who's tasked with this, so I'm gonna wait for his feedback on this issue. Let's push that one. Okay, so let's check for the aluminum chassis. Pick a box. I think we did discuss about it, so oh yeah, no, we don't have any. Okay, we don't have any reference, I think, anywhere. We need it for improved ergonomics. Yes, we do. But I do need a reference, and yeah, nobody was assigned to this. I'm gonna assign Wojciech on that one, and maybe we can have a look. Hammond Manufacturing. Well, I would say if it can please the eye, it's good, but whose eye does it have to please? Everybody is gonna have different opinion on that one, but we will try to make it as pretty as possible. We want to go for an extruded one, and we do believe that we are able to find one on which we can make FR4, basically use a PCB for the face, the front face and the back face. So let's have a look. Okay, so maybe not. Well, yeah, okay, so we see that there are some rails here on which we could slide the PCB. Oh, we can pick the color, so pretty. Oh, we can use like this kind of boards to make it real old school TNC looking. Oh, we can pick all kind of color accessories. Very nice. Maybe a bit too much. Anyway. Okay, so I think we'll just have a look at those, see if something seems to stand out. Maybe we can also have a look on DigiKey, see if they have anything to sell ready-made. Boxes. Hammond Manufacturing. Okay, can we have like we don't have any like extruded things. Okay. Okay, it looks like there is lots of different ones. Material. Aluminum, please. Okay, they do make a load of boxes. This is way too small. It's 8 centimeters by 5.4. Cast zinc box. Yeah, like if you want your module 17 to be outside for some reason, you might want to use that, maybe. I don't know. Okay, this seems to be quite large. 12 by no, this is not there. This is 12 by 28, 78. Sorry. It would be very good if we can have a box which is like just under 10 by 10 inside, so that we can just stay below the JLC PCB cheap range. I don't know though if we will be able to find any which fits those requirements. And yeah, I do believe that's it's gonna be very hard to find whatever we need. Yeah, it's gonna be a nightmare. Well, maybe, let me think. So would it be a problem if we have a box which is 12 centimeters long for a PCB which is 10 centimeters long? We would have to find a way to prevent it from moving around. I'd like the Module 17 case to include a modified PMR radio. What? I'm not sure I'm following you, Jens. To include a modified PMR radio. What do you mean? Oh, you mean having a Module 17 case which is large enough for you to put a PMR radio in it? I mean, what we could do is like decide on using. We could decide to use like something like these, which are 10.4 millimeters, centimeters wide, 12 centimeters long, and if you want to use one which is 16 centimeters long, you can just, it will fit and go inside. You will have to find some restraining mechanism. So let's have a look maybe at what is the difference between those. Flanged panels. Oh, okay, yeah, okay, I see this. No, we don't need flanges, I guess. Well, we for sure, I can say that we won't take into account any other requests than the one which are on Taiga, or maybe one which are based on bugs of the current design. We won't add anything new, and designing the box on such a specific need would be not feasible. But I do believe that you will be able to make it work in whatever box you want to choose later on. So looks like something like this could be good enough. Like, okay. Those I guess are feet to put below. Do you have any drawing? Yeah, we do. Okay. And those are 2 millimeters high slats. Knowing that the PCBs are 1.6 millimeters, I have absolutely no idea if just like 0.4 millimeter is just what we need for the clearance. Also, we sure don't want it to be too tight, otherwise we are gonna tear the solder mask or whatever finish we put on the sides. Trying to think about, oh yeah, okay. Oh, now that I yeah, okay, so we will need to make, okay, I think I'm understanding how we could do the assembly. So we could, for example, have, so let's take this box, let's say that we use this one. We make a board which is 10 by 10 millimeters. I do believe, yeah, okay, so this is 10.1 centimeters. Sorry, yeah, so 1 millimeter is enough wiggle room, I guess. We would put the PCB, slide it in, and on this, the front face here, we would make a PCB with the writings for the connectors, and then through the PCB we would be able to connect, to put a screw, so that the face that you see on the sheet, on the screen here, and the PCB can be screwed to one another, so the PCB won't move around in the case. And then on the other side here, for example, we would put the OLED connector and the buttons. So yeah, we would have like one face with the connectors and the screw, and another face with the buttons and the screen. How would that look? I don't know. I quite like this idea actually. Might be interesting to explore. Yeah, especially so I see that it's 10.1 centimeters plus or minus 0.75 millimeters. So in the worst case scenario, we are at 100.25 millimeters, which will be barely what we need for the PCB. So I think a 10 centimeters wide PCB here is good. And then we can make a 10 centimeters long PCB. And we'll have like, yeah, a bit larger PCB, which will be the maximum size for the JLC PCB prices. It's always the same. Yeah, so if you do it like two layers, 10 by 10, 5 PCBs, it's like €2 or $2. And as soon as you go 1 millimeter above, oh, actually, they don't seem to care much, or is... Oh no, yeah, okay, then it goes higher. It's not much higher, but... Okay, that's funny. I don't know how they compute it. Looks like they have like a few millimeters tolerance on this. Oh, it's 2 millimeters tolerance it is. Okay, well, good to know. I don't know if it's a bug or whatever, but you can go up to 102 by 102 millimeters. Anyway. So we had this one, so we have rubber feet to put below. We would design a face to put here. But so also to remember is that we don't have to... You can use the Module 17 without the case, that's the goal. So you will have still the keys on the PCB, but you will have a connector to which you can add external keys. So we can release version 1 and then release the case after. Okay, what is this? I'm not even gonna try to pronounce it, sorry. Oh yeah, okay. It looks quite nice. What kind of design does it use? It looks like it's the same kind of extruded aluminum box, except that it does have a, like, yeah, transparent top. I mean, as long as we use a form factor which is common enough, then people will be able to reuse it and put it back in any case they want. So if we have a look in here, aluminum, extruded aluminum, and with, oh, 103, okay, rounded rectangle, length, oh, 103, yeah, okay, this clear, rounded rectangle, aluminum end panel or plastic end panels. Okay, I don't know what they call clear. Can I put this website in, yeah, in English maybe? It's easier for you to follow. I guess clear is just like gray. Yeah, okay, anodized color. Okay. Right. That looks very nice. Quite like this. Oh, okay, and we have the aluminum plate in the front that we can swap for an FR4 maybe. But maybe it does need to be Front Panel Designer is a free software and can also be used for 3D prints with conversion software STP STL. Okay, why not? Okay, yeah, this one, how is it made? it does look like it's just a plate, 1.6 millimeter thick. In which case, oh yeah, exactly, 1.5. Well, in which case we can just like, oh yeah, using this would be perfect actually. You simply unscrew this and replace it with a PCB. So you don't even have to machine it. Yeah, the space in between for the slot height, it's 2 millimeters, which yeah, it's what we. It was the same as the previous one, and from edge to edge, it's 10 millimeters. 10 centimeters, sorry. So we may want to do, if we use this one, we may want to do a board which is just a tad bit smaller. The board just a tad bit smaller, so that we don't have like clearance issues. Red one is very nice. I quite like it. Maybe we can have a look here. Yeah, okay, it's quite a bit. It would definitely make it the most expensive part on the board, I think. Oh yeah, okay, so they advise to make like boards which are 99 millimeters wide. It's made for printed circuit boards, which is exactly what we are doing. So it's great. And so it does exist in a longer form factor. Yeah, even like much longer, 220. So then you are able to add whatever you want. You can make holes on the top if you want to. You can do, yeah, really whatever. Okay, I'm gonna add some comments on Taiga, and I hope that we will start a discussion on this. Okay. Trying to see. I think I did almost everything I could for today. So those, I want to wait for the new board shape. Oh, this I can do. This. And then this will also have to wait for the new board shape. Okay, let's... so basically the problem that we had is that I don't know what exactly, but there was a problem with the this resistor divider. I don't know, maybe it was just not put in place in the order of the ones we ordered previously. I don't know. This pin will sense the voltage, and this voltage in combination with the voltage on another pin, which we'll have to find right now, will determine the revision of the board. So this pin will have to be at half VCC, or VDD, it's the same basically. So we will put two 10K resistors here, and we will find another one to use. We'll go in, just maybe the datasheet would be enough for this. Pin description, which, how many pins do we have? I guess it's the 64 pins. Yeah, LQFP 64. So that's this one. Okay, we may want to have a look at no, not that. Show me the schematic. Yeah, perfect. Oh, come on. Okay, so basically we have to find a free pin here and see if it's compatible, if it's plugged to any tied, sorry, connected to any ADC inputs. PA0, where is it? PA0 looks like it's not. Okay, bedtime. Well, good night, Poacher. See you later. Thank you for following along. Well, it looks like it's connected to the ADC input 0. So we use PA3 for now, which is input 3. So yeah, we could maybe just use PA0, I guess. What about PA6 and 7? Yeah. PA0, what is it connected to? It's a wake up pin. Connected to user 2 Ethernet timers. And what about PA6 and 7? SPI timer event SPI. Well, maybe I will just use PB0 because it's not connected to anything very interesting. Some timers, I don't think we are gonna use at some point, maybe, at least not those ones. USB on the go, Ethernet, timers, and event outs. We don't really need that. So nothing very interesting connected to it. So there is very small chance that it gets used for anything at some point. So let's use this. Yep, like this, and tie it to ground. So for revision 1, this is gonna be VCC, half VCC, and this is gonna be ground. So let's add a node alongside it. No, sorry. Maybe I should yeah, you know what? I'm not gonna just tie it to ground like this. This can be a bit dangerous. If for some reason this pin gets set to any voltage, this can create a short circuit. So we'll just use 10K like this, populate it, set to grounds, and what R60, how well I'm not following. 68, yeah, we were up to R70, I think, so it would be R71. So I think this is just what we needed. Nothing. We don't need anything more. Oh, I can't change the alignment. Okay. Can I very quickly import those on the microcontroller? Save that, import this. Okay, we have, oh, we haven't set any footprint for the OHIS connector. Oops. We can set one. It's not a problem. Those tend to be very generic footprints anyway, so it can be quite easy. Connector, RJ, I guess. I don't think there is any other kind of connector, other kind of library that we can use. What does this look like? Oh. I thought it would have been more. If I do like this, does it allow me? Does it complain here? No, okay. It does complain. Okay, that's not a problem. We will take care of that later on. Ah, looks like there is not much room. We'll have to go. Let me just pick smaller. What kind of thing it is? 0603. Okay, and then oh, music stopped? Really? Okay, let's try not to mess up everything. So I'm not gonna try getting things too tied up, too tidy. Not the goal, because we are most likely gonna have to revert back to another design, to change another design later on. So there is no point in that. Let's pick the correct size for the via. Keep this aligned, so this is aligned with the rest. Looks fine. Okay, I refilled the planes, and I think it's gonna create just a large amount of changes on the file, so I'm not able to view it. That's not a problem. Here, okay, a few changes here and there. Okay. I can also copy the commit and go on Taiga, set this as closed. Go here. Okay. Well, I think we did quite good today. I think it will be time to slowly go to sleep though. Oh, I see that I have a response from Mark. I don't know, Mark, if you are listening in any way. Okay, for some reason I can't get... I think I messed up something. No, I think it's good, okay. Mark, if you are listening, give me a sign. Do something. Or maybe... let's wait to see if Mark is still connected and still looking. So basically Mark says that we should not tie VCC to anything. Oh, and Steve, if you are still listening, well done for containing the Taiga notifications in a thread. You did that just as it needed to be. Perfect. So in the meantime, let's have a look at the board. 3D viewer. Yeah, so this is what the board looks like for now. So here is the place for the OLED screen. And here are the keys that you use to navigate the menus. So you have here connector for the packet radio. This, I guess, is the USB-C. This is the 12-volt barrel jack, in case you want to power it with external power, but USB-C does the job too. This is the MCU, and yeah, TX filter, RX posts. You have a UART if you want. I don't think it is used though. So yeah, the board is very well done actually. I like it with the boxes with the names of whatever is inside. It's quite easy to understand what is going on. Power button here. And here are just a few connectors. And so the goal would be to make the board a tad bit larger, a tad bit longer, so that we have the space needed to add audio connectors. So we would have to remove the audio connectors currently on this side. We would have to move them on the either the back or the front. I don't really know that. I guess the back would make more sense given how we would design the box, the enclosure. I don't know. This connector takes quite a bit of place though. We have talked about changing it for another one maybe. So maybe if we see that we struggle to connect, to put everything, all the connectors on the correct sides, then we will have to swap it for a smaller one. So currently the PCB is 90 by 85, and we could make it 99 by 85 by 10. Sorry, 99 by 100 millimeters. So let's pick a layer, drawing layer, and create a square. If we start from here, we can see how much larger it is. So yeah, that just, I think like this might already be enough to put 8PHC connector. We just, okay, we have the speaker volume here. This I don't know how we would handle it. I do believe that having it on the back would make it too hard to reach. I also believe that the connector on the back would be a bit counterintuitive, but given that the design, given how we want to design it, I think it would be almost the only way. Anyway, no response from Mark right now, so I think I'm gonna close the stream now. Say goodbye, and we will be able to discuss it maybe off stream, and next stream I hope that we will have more information on what to do for the box, the enclosure, and the audio part. If we do, then we will be able to move forward easily. Otherwise, well, I think there is no point in having another stream if we don't have more information on what to do. Anyway, I think this was a good stream for the new season, let's say. or whatever we want to call it. I don't know. Thank you for following along. I hope you enjoyed it. I hope we will see you next time. Take care, 73s, and bye bye.